Good day po sa ating lahat and welcome to Kuya Jason, and nandito po ako to add value. I just want to remind you that you are blessed, you are favored, and you are extraordinary. At kung bago po kayo dito sa aking channel, kindly subscribe this channel para po ma-notify po kayo sa ating po mga videos. At ganun din po, if you have some topics na gusto nyo po na discuss po natin dito sa ating videos channel, so you can comment it down on this content. Maraming salamat. I hope that you will enjoy listening this content. Have a great day. Once again po, good morning po sa ating lahat. Sir Jason here at Kuya Jason's channel, and I am here to add value to my students. Ngayong araw, mag-usapan naman po natin ng isa pang topic about sa computer system servicing. Welcome to my students. Hi and hello. How are you today? I hope that you are all good and learning in our lesson. Ngayong araw, pag-uusapan natin ang 7 quality control tools. On the past lesson, diniscuss natin at pinag-usapan natin yung tungkol sa quality improvement. And in order for us to fully engage in quality improvement, we have 7 control tools that we can use that can assist us in identifying the problem and creating optimal solutions to all the problems and the root problems. Ang una ay tinatawag natin na flowchart. Flowchart describes the process in as much detail as possible by graphically displaying the steps in proper sequence. A good flowchart should show all process steps under analysis by the quality improvement team. Identify critical process points for control, suggest areas for further improvement, and help explain and solve a problem. Flowcharts can be simple, such as the one featured on the next slide, or they can be made up of numerous boxes or numerous steps. They can also be made up of numerous symbols and if or then directional steps. In more complex version, flowcharts indicate the process steps in the appropriate sequence, the condition in those steps, and the related constraints by using elements such as arrows, yes or no, choices, or if-then statements. So I have here an example of flowchart. So makikita natin dito ang example ng isang flowchart. So, this is a simple flowchart. So, pinapakita dyan kung ano yung gagawin kapag yung lamp ay hindi nag-work. So, this part indicates the start and this part indicates the action. So, it indicates a process. Like this. If lamp doesn't work, you need to plug in. The bulb. Okay, plug in the bulb. Yes or no. Okay. And then, when the bulb burnt out, if yes, you will replace the bulb. And if no, you will repair the bulb. So, it shows a simple process. Next is, meron po tayong tinatawag na check sheets. Check sheets help organize data by category. They show how many times each particular value occur, and their information is increasingly helpful as more data are collected. More than 50 observations should be available to be charted for this tool to be really useful. Check sheets minimize clerical work since the operator merely adds a mark to the tally on the repaired sheet rather than writing out a figure. By showing the frequency of a particular defect and how often it occurs in a specific location, check sheets help operators spot problems. The check sheets examples show a list of molded part defect on a production line covering weeks' time. One can easily see were to set prioritize based on the result shown on the check sheet. Assuming the production flow is the same on each day, the part with the largest number of defects carries the highest priority for correction. Ito po ay isang example ng check sheets. So this is a check sheet on computer-related problems. So we have problems indicated. We have network problem, server problem, email, and server access. So by looking on the tally, on week 1, 2, 3, and 4. So we can see which of the following problems contribute to the greatest defect. And we can see that the email contributes to the majority of the greatest defect. Next is the server access. Third is the network problem. And last is the server problem. Therefore, we can conclude that we have to prioritize the largest one, which contributes the greatest number of defects, which is email. So that is how a check sheet is used. The next is we have what we call the Pareto diagram. The Pareto diagram is named after Vilfredo Pareto, a 19th century Italian economist, are caused by 20% of the potential sources. A Pareto diagram puts data in hierarchical order, just like what will be shown on the next slide, which allows the most significant problem to be corrected first. The Pareto analysis technique is used primarily to identify and evaluate non-conformities. Although it can summarize all type of data, it perhaps the diagram most often used in management presentations. To create a Pareto diagram, the operator collects random data, regroups the categories in order of frequency, and creates a bar graph based on the result. So the result of check sheets can also be turned into a Pareto diagram. So this is an example of Pareto diagram in the defects of shirts. So on this side, okay, we can see the number of frequency of occurrences of defects. So from 0, 5, 10, 15, 20, 25. And on the lower part, we can see the type of defects. So the higher bar represents, each bar represents the frequency of each defect. And we can see on the Pareto chart that the bottom defect contributes to the highest frequency of defects. Therefore, we can say that we have to prioritize correcting this defect so that the number of defects will be reduced, and therefore production will be increased. So that is how we use the Pareto chart. The next is the cause and effect diagram. The cause and effect diagram is sometimes called the Ishikawa diagram after its inventor. It is also known as the fishbone diagram because of its shape. A cause and effect diagram describes a relationship between variables. The undesirable outcome is shown as effect, and related causes are shown leading to and the said effect. This popular tool has one severe limitation. However, in that user can overlook important complex interactions between causes. Thus, if a problem is caused by a combination of factors, it is difficult to use this tool to depict and solve it. So we have an example of cause and effect diagram or fishbone diagram. A fishbone diagram displays all contributing factors and the relationships to the outcome to identify areas where data should be collected and analyzed. The major areas of potential causes are shown as the main bones. Later, the sub-areas are depicted. Through analysis of each cause can eliminate cause one by one, and the most probable root cause can be selected for corrective action. Quantitative information can also be used to prioritize means for improvement, whether it be to machine, design, or operator. So we have an example of cause and effect diagram. So the head of the fish is the problem or the effect. And then the end of the major bones represent each areas that may contribute to the problem or the effect. So this tool allows you to analyze each area that contributes to the problem and effect and list down which of the sub-causes on each area contributes to the problem or effect. On this example, we have the machine, the man, the material, the method. We have another example here. On this example, the problem is front-end checkout transaction is too long. Okay, that's the problem. So, on this problem, so we have different areas to consider. We have scan book, promotions, pricing issues, methods, RIM prompts, and manager overrides. Okay, so on each categories, we're going to check each categories and analyze which of their sub-categories really promotes to this main problem. Okay, and you can see in this diagram that there are two. We have the RIM prompts and the manager overrides, which causes most of the the too long hour of transaction in the front end checkout. So this tool is very helpful to identify the causes and the root causes of a problem. The next is we have what we call the histogram. The histogram plots data in a frequency distribution. What distinguishes the histogram from a check sheet is that its data are grouped into rows so that the identity of individual value is lost. Commonly used to present quality improvement data, histogram work best with a small amount of data that vary considerably. When used in process capability studies, histogram can display specification limits to show what portion of data does not meet the specifications. After the raw data are collected, they are grouped in value and frequency and plotted in a graphical form, which you will see in the next slide. A histogram shape shows the nature of the distribution of data as well as the central tendency or the average or the mean and the variability. Specification limits can be used to display the availability or reliability of the process. So this is an example of a histogram. So on the right side are the frequency and on the bottom part are the response time. So through the use of this histogram, we can identify on what time we gain the highest frequency and on what time we have the lowest frequency. The next is the scatter diagram. A scatter diagram shows how two variables are related and is thus used to test for a cause and effect relationship. It cannot prove that one variable causes the change in the other, only that a relationship exists and how strong it is. In a scatter diagram, the horizontal, the x-axis, represent the measurement value of one variable, and the vertical, the y-axis, represent the measurement of the second variable, which can be shown on the next slide. So this is our example. So this is the example of Scatter diagram. Scatter diagram measures the correlation between a variable and the other variable. So we have different kind of correlation. When the scatter diagram have close dots and they have uptrend, so that is interpreted as positive correlation. When the dots are plotted downward trend, so that is interpreted as negative correlation. And when there is no trend and the dots are too scattered, that is interpreted as no correlation, which means that there's no relationship between the variables. And the last is we have the control charts. A control charts display statistically determined upper and lower limits drawn on either side of a process average. This chart shows if the collected data are within the upper and the lower limits previously determined through statistical calculation of raw data from earlier trials. So we will see the example on the next slide. In preparing the control chart, the mean upper control limit or the UCL and the lower control limit or the LCL of an approved process and its data are calculated. A blank control chart with mean of UCL and LCL with number. So this is an example of control charts. So we have the upper control limit and we have the lower control limit and we have the average at the middle. So at this, and we can also see we have the measurement at the left side and we have the time at the bottom part. So we can see on what time does a process hits the lower control limit or hits the upper control limit. So that's the use of the control charts. Okay, so those are our 7 quality control tools. I hope that you learned from our lesson for today. Thank you for listening. God bless and have a great day.